Department of Mathematics, SNS College of Technology. Today we are going to do case study on computer network diffusion by using linear homogeneous partial differential equation with my students team. They are all from CST.
I am Shweta. I am Pankaj. I am Nalini. I am Shani.
I am Satya.
Myself Sanjita. I am Shari. I am Sonia.
Myself Samyukta.
Yes. So before entering into case study, first of all we should know what is linear equation, what is linear homogeneous equation. In that we are having two types. One is differential equation, another one is partial differential equation. So when we are talking about linear equation, we should have all the degrees as 1. So if we are having each degree as 1 means we can say that as a linear. If we are having the same linear equation, linear term as the whole equation mean, we can say that as a homogeneous. For each term, if we are having different types of degree means we can say that as a non-homogeneous equation. Now we are coming into differential and partial differential equation. Suppose if we are having only one independent variable means that is your differential equation. If we are having more than one independent variables means that is your partial differential equation. So here we are going to deal the partial differential equation by using the types of RHS equal to e power ax plus by, then we are having sine of ax plus by or cos of ax plus by and so on. So now we are going to enter into the case study.
In computer science, data sharing is an important process in systems like cloud computing, distributed databases and network. When data spread from one system to another, it follows certain patterns. These patterns can be studied using linear homogeneous partial differential equation, which help us understand how data changes over time and space.
Okay, imagine a situation where a company releases new software update. Initially, only few systems have the update, but over the time, it spreads through internet to other systems. Our goal is to study how data spreads from one node to another over the time.
Now let us see the concept explanation.
Little louder.
Now let us see the concept explanation. In this model, we consider the computer as a point. It will decrease or increase with the later rate and then it will changes with the distributions. So let us consider with the like computer has a various differentiations. So by changing the time, we can change it.
Linear nature. The system is called linear when the data flows in a simple and behaves in a predictable manner, and the change in data at any point is directly depends on the data of that point without any the system is called linear when the data flows in a simple and predictable manner. The change in data at any point is directly depends on the nearby points without any complex interactions.
The system is called as a homogeneous system because there is no external data from it. There is a data which is present in the system from the beginning, and the data are already initially stages. The data are already present in the system, and so the data are already declared and spreads in the system. So the key idea is there is no external influence affected by this data. It only work with its own data.
To simplify this study, the network is uniform. All nodes flow similarly. The data splits evenly. No loss of data or interruption. This is useful for beginners.
Initially in the system, only few nodes have the data. After time passes, few more data have been added and received. Eventually in the system, the data spreads over entire system also.
So now let us discuss about the interpretation of results and the application in computer science. So in this model shows that the data flows in a very smoothly manner and doesn't have any jumps or any irregular patterns in it. So this makes the users and the designers very easy to make it, and it is very efficient for them. So in application it includes like file storing in the cloud data synchronizations and data storage.
Conclusion. This case study explains how a linear homogeneous PED concept can be applied in computer science. It helps us to understand the data spreads in the network, which is important for modern technology. Even though the matrix behind it is complex, the idea is simple and very useful in real world application.
Yes, why we are studying this case study in the sense we all should know why we are dealing the partial differential equation while we are taking the diffusion. So diffusion in the sense we are transferring one data from the system to another system or one location to another location. So whatever maybe we are handling, there is a small rate of changes we have to come to know. So that is why we are dealing the diffusion by linear partial differential equation. Thank you.